Right, so in question one, we want to find basically where our functions are increasing, decreasing. So that means we need to find critical numbers in the first derivative. So first thing we need to do here is just take a derivative, f prime. We're going to get 4x cubed over 4 plus 3x squared minus 10x. And then we can cancel those 4's out. And we're left with x cubed plus 3x squared minus 10x. All right, so then we can take this and pull out a greatest common factor of x. So that's going to be x squared plus 3x minus 10. And then can we factor this? Yeah, this is going to be an x plus 5, x minus 2. All right, so here's our derivative. All right, so in order to find the critical numbers, we have to set the derivative equal to 0. So let's go ahead and do that. Do it up here. This is going to be about as straightforward as it gets, right? Just a little zero product property, right? So everything that has an x gets a chance to be 0. Right, so this gets a chance to be 0, this gets a chance to be 0, this gets a chance to be 0. Right, so we're going to get x is equal to 0 from this first one. We're going to get x plus 5 is equal to 0, so x equals negative 5. X minus 2 is equal to 0, so x equals 2. So we're going to have three critical numbers here, right? If I throw them in order, we're going to have x equals negative 5, x equals 0, x equals 2. All right, so there's our critical numbers, right? Our function was defined for all real numbers, right? So these are the only places which our first derivative can change. All right, so a lot of ways we can attack this, right? So one way to do a table of signs is to simply, whoops, I need three of them, is to know what your function is doing, right? So, sorry, know what your derivative is doing, right? So if I look at this, I have a cubic function, right? So I have a cubic, my lead coefficient is positive, right? So this means that our cubic is going to look like this. And since each of those, um, critical numbers appear just once, it's going to look like this. So negative, positive, negative, positive. But just in case you're like, I don't know that, well, then let's make a table of signs. So we could take this, right? We can take our derivative. And remember, the only thing we care about is going to be the sign, not the actual value of your derivative. So if we plug in something, right, here's my like f prime. That's going to tell us what f of x does. So if I plug in something less than negative 5, like negative 6, well, whoops. So that's going to be a negative 6 plus 5, right? That's going to be a negative number. Negative 6 minus 2, that's going to be a negative number. I have three negatives, an odd number of negatives. So negative, so that means that our function is going to be decreasing. If I plug in a number between negative 5 and 0, like negative 1, right? So negative 1 is negative. Negative 1 plus 5 is going to be a positive. Negative 1 minus 2 is going to be a negative. Two negatives, so that means that we're going to give a positive. So our function is going to be increasing. If I throw something between 0 and 2, like say 1, positive, 1 plus 5 is also positive, 1 minus 2 is negative, right? So only one negative. So our function is going to be decreasing. And then if I throw something in greater than 2, we're going to get a whole bunch of positives, like 3. So that's going to be a positive. 3 plus 8 is positive. 3 minus 2 is positive. Bunch of positives. So we're going to be increasing. So at this point, well, we know where our derivative is less than 0. It's less than 0 from negative infinity to negative 5. And then again, from 0 to 2. This is going to be where our function is decreasing. So these two should be the exact same. Where's a function increasing? Well, it's increasing from negative 5 to 0. And then again, from 2 to infinity. So this is where our function is going to be increasing, right? So these two things are always going to be the same. All right, so we want to find the critical numbers, our maxima. So let's see. So if we look at our function, we're going down, then up. So this is a min. We're going up, then down. So this is a max. We're going down and up. We're decreasing, then increasing. That's a min. And so we know that negative 5 and 2 are our minima. So x equals negative 5, x equals 2, x equals 0 was our only max. To find these values, we have to plug them into the function. So I'm going to do the first one, then I'm just going to be lazy and throw into technology. So if I want to find, say, the max, I can throw in 0. So 0 over 4 plus 0 minus 0 plus 2. So our maximum value is going to be 0, 2. It's going to be the y-intercept in this case. So I'm going to be a little lazy. I'm just going to pause this, throw it into Desmos for a second, so you don't have to like watch me pause this. All right, so I just threw my function into Desmos, so I'm going to plug in a -5 and a +2. So I did a couple of ways. We can obviously see the answers right there and there. But if I just threw it into like a function or a table, one thing that I could do in my table, I could just find to see if it says it right, 2, -6. I could also in my table just plug in like -5 for x if I wanted that way. I could also, right, if you define it as f of x, you could always do like f of -5, right, that way. All right, so tons of different ways that you could get these mins and maxes. All right, so either way, it's negative 91.75. So 5, -5, sorry, negative 91.75, and 2, -6. Those are going to be our minima of the function.